It's time to begin, so we'll go ahead and get started. What you see on the board are the two problems that we started on the handouts that I posted for you. By the way, I also posted these in Blackboard as an assignment. You're going to have to complete these and make a copy of them and submit them like we did back before using Blackboard by Friday at 10 p.m. Now, as we go through these, you're welcome to make corrections, and if you've made corrections, then you can count them as correct. Altogether, there are 86 problems on your set of handouts that are in this PDF. So we're going to go through these today. Now, tomorrow, I also gave you an assignment. There will not be class tomorrow at all, neither online nor in person. Tomorrow I'm giving you the day off so you can work on this handout to get it completed. And then we'll start grading it then on Thursday and finish up and with the test review on Friday. And then next Monday, you'll have an in-person exam 2, just like we had in-person exam 1. So that's kind of where we're headed. Yesterday, I brought you this far, and then I told you, well, you can look up in your calculator square root of 13 and multiply it by 2. I have that done on my facsimile calculator over here. One little thing that I want to show you is when you first put in this value in the calculator, you might get an answer that just looks like that, which doesn't tell you anything. If you use this standard equals decimal key right here, then that will toggle you back between a standard form answer and a decimal answer. It's not real obvious what that key is. Okay, that said, let's go on to problem number 3. Okay, on problem number 3, again, we have to find the distance. We chose to call this point 1 and point 2. Yesterday, I called this point 2 and point 1. I actually prefer to do them left to right, 2 and 1, so they just fit into the formula nicely left to right. But it works this way too. So if this is point 1 and that's point 2, then we first look at the x values, and we have 0.2 x value minus a negative 0.1 x value squared. We have 0.2 y value minus 0.1 y value quantity squared. Okay, we add these two, gives us 5. Add these two, gives us -3. We square each of these. 25 plus 9 gives us 34. And then we want to change that to a decimal. Because this is a rounded off value, we have to use the approximately symbol. Now, I'm going to show you something on the calculator that you can do, although it's not necessarily a faster way to work this problem. So let me clear this one. And I'm going to put this entire problem in the calculator. And that's the nice thing about these Casios, because what you put in is exactly what you got. So I'm going to take the square root right here. And then inside that square root, I'm going to put parentheses and 3.8 minus negative 1.2, close the parentheses and square it, plus parentheses 1.5 minus 4.5, close the parentheses and square it, and equals, which that I can then toggle back and forth to the decimal value. Okay, so you can see how we put this in, just like it was in the problem, and that's the beauty of this particular calculator system. Okay, problem number 4. Another similar problem, except more complicated. So I put in negative square root of 3 minus negative 6 square root of 3, quantity squared, plus 2 square root of 6 minus square root of 6, quantity squared. Okay, we simplify these. There's a negative 1 of these and a positive 6 of those, giving me 5 square root of 3's. Over here, I've got 2 of these minus 1 of these, gives me 1 square root of 6. Okay. Now, I square this and I get 25 times 3. The square root of 3 squared is 3. 5 squared is 25. 3 times 25 is 75. They left out a step. Okay, now for this part, it's just 6. We add these, we get 81. Square root of 81 is 9. Problem number 5 was a rather lengthy problem. Determine if these are the vertices of a right angle. Okay, what we've got to do is find the 3 distances and then try those 3 distances in the Pythagorean theorem to see if they prove to be true. So first, if we want to find this length from A to B, we put in the values for A and B, and we get square root of 32. Then we try for A and C, and we get square root of 50 when we use the A point and the C point. Then for B and C, we put in the values, and we get square root of 18. Now, it's obvious that in this drawing right here, this is the longest side. So this has to be the C in the Pythagorean theorem. So this side, which in this case would be square root of 32. This side, which is square root of 18. We square those. And does that match square root of 50 squared? Well, 32 plus 18 does in fact equal 50. So yes, the answer is yes. Now, in reality, I don't expect a problem as lengthy as this one to be on the final for time reasons. You might have to do one like any one of these individual ones, but it's unlikely on the final that you'll have to do all of that. Okay, now we move to the midpoint formula. Here we have the midpoint formula. Okay. So in this case, we are averaging the X values. We add them together, divide them by 2. We're averaging the Y values. We're adding them together, divide them by 2. So now we take the X values here, negative 1.8 and positive 4.5, add them, divide them by 2, and we get 1.35. We take the Y values, negative 3 plus negative 1, divide them by 2, and we get an answer of negative 2. So our answer then would be 1.35 negative 2, or in fractional form, 27/30ths. Or 20ths rather. Oh, by the way, in case you're wondering how you got that 27/20ths, if you take 135 over 100 and reduce it, okay, 5 goes into this 27 times. We're going to divide by 5 over 5. And 5 goes into this 20 times. We actually could have done it from back here, but there wouldn't be any advantage. And I'm missing an eraser. See if I can find one. Have to clean the chalk dust out of it. Okay, graphing the equation. We're given a quadratic, okay? Now, in this case, they plotted points. We could have, since they said plotted points, you have to pick some X values and find some Y values, okay? Now, we could have done this by transformation, just, Y equals X squared plus 3 is the equation. The Y equals X squared equation looks like this. Something like that. So we could have just taken this one and shifted it up 3 places, 1, 2, 3 places to do it by transformations. Unless it tells you to plot points, the transformations are going to be much faster generally. Now, you would not have had to have had these same points, but you need to have, in this case, some positive and negative ones because of the square. Now we've got the square root of X plus 3. Here, this plus 3 that's contained with the X is going to shift the basic graph 3 places opposite of sign. So it would have started here, here, and here, and so on. But it shifted everything 3 places to the left. Here is a plot of points. Notice again, we're using 0, 1, -1, 2, -2, 3, -3, and 3, and so on, as our typical graphed values. This time, they've thrown a quirk into it. This is not Y equals X minus 4. y equals x minus 4. Get my drawings out of here. This equation is x equals absolute value y minus 4. That's the problem that this is. Now, if we had the equation y equals absolute value x minus 4, then it would be one that starts here, but shifts 4 places to the right. 1, 2, 3, 4. So in other words, it would go up like this and likewise like that. So this would be the equation y equals x minus 4. In other words, starting at the orange, the V, move 4 places right. But yet this one is x equals y minus 4. So in other words, we shifted y up 4 places opposite of direction, with x being our y being our axis that we're going on. Those two equations are reciprocals or inverses of each other. Okay, here they're doing it again. Instead of giving you a simple equation of y minus x squared plus 2, which could be changed to y equals x squared plus 2. In other words, take this equals 0. In other words, take this on the other side, and then I've got to make that a negative. There'd be an intermediate step, but this would become that. Now, this equation, easy to graph. Take the basic equation, move it over 2 places to the right, 1, 2. Like so. Okay, we'll get rid of that basic one. And it would look like this. Okay. This one, on the other hand, x equal y squared minus 2. Okay. Here, we're shifted 2 places to the left, and this is flipped at 90 degrees. Just like our V was flipped at 90 degrees earlier for the absolute value problem. Okay. Okay, identify the x and y intercepts. This one is relatively simple. Okay. Right there is where it hits the y-axis at the point 0, 3. Right there is where it hits the x-axis at the point 3, 0. And I don't think you can see my pointer. So I'm just quit trying to use it. Okay, here, how about I erase my scribbles? On this one, the x-intercept, you have a pair of them. The y-intercept, there's only one. By the way, each problem is an all or nothing. There are 86 total problems. Problem number 13. Find the X and Y intercepts again. Okay, the process here is to find the X intercept, you're going to make Y equal 0. To find the Y intercept, you make X equal 0. So, to find the X intercept, we make Y equal 0, solve the equation. X squared equals -9. If we take the square root of both sides, plus or minus, we get an imaginary number. And we can't graph that. So there is no real x-intercept in this point. That means that this equation does not cross the x-axis. It's a parabola that either looks like this, or if it were a negative x in the equation, when you take this over here, then it would go downwards. But in this case, it would be upwards like that and never touch the x-axis. Now, for the y-axis, what we do is replace the x with 0, and we get just simply 9. So the point 0, 9 is where your graph is. So in reality, this equation is going to look like this, where this is the point 0, 9. Number 14, we got these reversed. So this V is going to go that way instead of this way. Now, once again, we replace all this equation, all this asks us is to find the y and x intercepts. So to find x, we replace y with 0. So we're doing that. Okay, gives us -3. Absolute value of -3 is 3. Plus 2 is 5. So the point 50. Remember, when we ask for intercepts, your answer always has to be in point form, not just a value. Okay, for the y intercept, we replace x with 0. This, here we move the 2 to the other side. When we remove the absolute values, we have plus or minus, but it's impossible to have an absolute that comes out a negative value. So that's why we just say no solution on this one. Okay. So in this case, well, no solution. There is no y-intercept. So in this case, what this problem does, here's the graph paper, and this particular graph is going to be 3 to the right and 2 up, 3 to the right and 2 up. So this one is going to look like that, and it never crosses the y-axis. Now we've got a harder problem this time. This one involves quite a number of steps. Okay, we've got this, and over these. Now keep in mind All they're asking on this problem is what are the intercepts? This, you see you have a x squared, you're also going to have a y squared equals a number. You might think, well, is this going to be a circle? Actually, it's going to be an ellipse, an egg-shaped oval, okay? But we don't need to worry about that for right now. All we need to care about are the x and y intercepts. So for the x-intercept, we replace y with 0. So we do that. 3 squared is 9. Okay. Find the common denominator, which is 36. You multiply everything by 36. Okay. They're doing it slightly differently. The way I would do it is I would take this by 36, this by 36, this by 36. That cancels once there 4 times. That cancels once there 9 times. And that doesn't cancel. So I would end up with 4x squared plus 9 equals 36. Take the 9 over. Okay. Minus 9, 4x squared equals negative 25. Okay, so divide both sides by 4. Well, at this point, I'd probably take the square root of both sides, plus or minus. But look what happens. I've got a negative radical. So the answer is no solution. They basically came to it a slightly different way here. And they're going to have no solution. Okay. And so let's go to the next problem. Or the x-intercept rather, or the y-intercept. In the case of the y-intercept, we replace x with 0. So that wipes out this whole piece. So we get y plus 3 quantity squared over 4. What they did is they multiplied both sides by 4 here. And over here, then it canceled. Multiplied this by 4, multiplied this by 4. Okay, and like so. Now, they took the square root of both sides. They didn't show it. And they did show it on this side. Okay, so here we get y plus 3 equals plus or minus plus 2, and y plus 3 equals negative 2. Okay, so you take this 3 on the other side, so you get negative 3 plus or minus 2, which gives you the two values of negative 5 and negative 1. So there are 2 y-intercepts in this case. Okay, and no x-intercepts. What does that mean graph-wise? In this case, you're going to have something like this. We are not going to study ellipses as part of this course. Just circles. Speaking of which, that wasn't meant to be a pun. Okay, we've got a little bit of a review here. Here's your basic format for a circle. H and K give you the center, opposite of sine, and square root of r squared will give you R, the radius. Now, this radius has to be a positive number, something bigger than 0. Okay? If it's 0, then it's just a single dot. So it has to, R has to be a bigger, a positive number greater than 0. Now, graph the circle with the center -3, 2 and radius 4. Well, here's your center. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then you draw, you fit the circle, fit the curve. They call that curve fitting. Okay? And what is the equation based on this? We have x minus -3 gives us x plus 3 quantity squared, and y minus 2 quantity squared, and 4 squared is 16. So there is our equation. So we got the equation, we got the graph. Okay, so move that down just a little bit so we can see everything. There we go. Write the equation in standard form and graph the circle. Okay, standard form is that x minus h quantity squared plus y minus k quantity squared equals r squared. So we take the center, put in the x value, put in minus a negative on the y value. We have the squares, and radius squared is 4. Simplify this, x minus 0 is just x, so x squared. Y plus 3 squared equals 4. So that's the equation. Now, to graph it, the point 0, -3, here's down 3, is the center with a radius of 1, 2 in every direction. Problem number 2, x minus 4, y minus 3, and 3 squared is 9. So here's your equation. The point 4, 3 with a radius of 3 in every direction. By the way, in ALEKS this weekend or between now and then, when you're working on graphing circles in ALEKS, always magnify it so you can fit the circle a little better. You'll be less likely to get an error called on you in ALEKS. Another similar problem, they give you the center. This time they tell you it's tangent to the y-axis. I worked a problem very similar to this one in class. You put in these values, opposite of sine, opposite of sine. They don't tell you the radius. So based on this graph, if here's the center, the just touch value of the y-axis, that's what it means where it just touches the y-axis. That's what tangent to the y-axis means, is a distance of 3 units. So our radius is 3, r squared is 9. If this said tangent to the x-axis, okay, well, in this case, if it said tangent to the x-axis, then the circle would have to be like this. And the radius would be 2. Actually, I didn't draw that very well. Like so, if it said x-axis. Okay, we talked about the general form in 1 or 2 examples in class. All that is you FOIL this and you get x squared plus 16x plus 64. You FOIL this, or you can use that shortcut, the a squared plus 2ab plus b squared thing. And this one you get y squared minus 2y plus 1. They move this 25 over to the other side. They combined all the whole numbers, the 64, the 1, and the negative 25 to get 40. So here you have x squared plus y squared plus x's minus y's plus numbers. So that's the order: x squares, y squares, plain x's, plain y's, and then numbers equals 0. So there's your general form. Okay, functions and relations. This is section 2.3. Let's see. Yeah, I think that'll work. Okay, remember, a relation is just anything that can be represented by ordered pairs. Okay, x is the domain or the independent variable, y is the range or the dependent variable. The value of y depends on what the value of x is. Now, a function, we say that y is a function of x if there's only one value of y for each x value. Okay, and we had some examples of that, which we'll be going over problems again. Now, here's a set of points. We've got the domains, the 2, the pair of 2's, and the 3. Now, what this is saying here is I've got the same x value with 2 different y values. So that does not fit the definition of function because there can only be one y value for each x value. Okay, so this is not a function. Problem number 2. In this case, we look at this. We have unique x values. Yes, we have the same y value for an x value, but that's okay, because what that might represent, okay, is if we have, here's the graph, we've got the value of x equals 1 and y equals 3. And we've got the value of x equals 2 and y equals 3. And we got the value 3 and y equals 5. This could be part of any figure. It could even be part of a parabola. We don't know. But because of the vertical line, there's only one y value for each x value. So this one is a function. On number 3, they're doing it with the Venn diagrams. They say that -2 maps to -2, a y of -2. X value 6 goes to 6. Pi goes to pi. Well, what's that looking like graph-wise? -2, -2 is here. 6, 6 is here. 3.14, 3.14 is here. Actually, probably about here. We're really talking about a straight line and vertical line, only one y value for each x value. So this one is yes. Number 4, this is a line, so it's going to be yes. This one is a parabola. What is this parabola going to look like? Well, okay. First place, it's going to start up here. That's what this does. And that 2 times makes it steeper. So it's going to look something like this. But still, the vertical line test, only 1 point per x value. So that one is yes. Okay, there's 7, 8, and 9, or 6, 7, and 8. Number 6, even though they put it in backwards order, you can see you can rewrite it as y equals 7 minus x or y equal negative 7 plus x. That's a line, all lines are functions. Okay, now number 7, when we get it and you graph it, it's going to look something like this. So there are 2 values for each x value. In some cases, there'll only be 1 right there. But in other words, that one would not be a function. And in number 8, okay, y cubed equals 7 minus x. We simplify it to y equals cube root of 7 minus x. Well, what is this thing going to look like? Here is the basic y equals cube root thing, and this 7 is going to shift it 7 places to the left, and this x is going to flip it. The 7 places to the left would make it cross here and go like that and down like this. And then the negative here is going to flip it across the y-axis. So this point becomes your flip point. So it's going to look like that as your final graph. Now, does that meet the vertical line test? Yes, it does. And by the way, this was a real difficult transformation on this one. Okay, the vertical line test, I've been talking about it all along. Here, we got 2 values for the same x, 2 y's for the same x, so no. Here, only 1 y for each x. So yes, this one, this piecemeal graph, here we've got, because this is an illustration of what you've got on these 2 points right here. Since this one is not included and this one is, there's only 1 point there, so it would be yes. If both of these were included, then the answer would be no. Okay, on number 12. By the way, I hope all of you are copying these down, because then you can still get full credit for them. Okay, evaluate. Evaluate, the word evaluate, if you recall, means just sub and solve, plug and play. Okay. In this case, it tells us replace x with -3. So we replace it here and here. Square -3. -3 times -3 is 9. You get 28. So f of -3 equals 28. F of square root of 2. We replace all the x's with square root of 2's. Square root of 2 squared is 2. Here, it's just there. So you get 2, which is 4, minus 3 square root of 2 plus 1. The 4 plus 1 is 5. So 5 minus 3 square root of 2. If you replace A, you just replace A. Nothing more you can do on this one. Here, this one's a little complicated. You replace that parentheses for the x. Now you've got to FOIL this. Gives you 9 minus 6z plus z squared. We'll have to distribute that. Minus 3, -3 times 3 is -9. -3 times positive z is -3z. Now we multiplied that out, we combine like terms, and we get this. 2z squared plus 9z plus 10. Number 13 will be the last problem we go over today. Okay, so in this case, y equals this, and we're replacing with a 3. So we replace the x with 3. 6 minus 6 is 0. Square root of 0 is 0. We replace x with 4 here. 6 minus 8 gives us square root of -2. That's an imaginary value. Square root of 2i. So it's undefined. Here we replace it with -4. -2 times -4 is -8. 6 plus 8, negative times negative is 14. Okay. And in this one, we're replacing it with 2w. So 6 minus 2w gives you 6 minus 4w. That's as far as you can go with this one without knowing what w is. So that's a good stopping place. Tomorrow we will take over with problem number 4, or not tomorrow, but Thursday. We will start grading these, because by Thursday class period, you should have all of the rest of this sheet finished, ideally. So again, if you have something wrong as we go over these on Thursday and finish up Friday, then as long as you correct it, you can count it as a corrected value and get credit for it. So now I'm not wanting you to wait until Thursday to write them down. I'm wanting you to work them ahead of time. That way you're getting the benefit of it. I hope there are no questions. Again, no class tomorrow. I'm giving you the time to work on the rest of this sheet. Thursday we'll come back and we'll begin grading these. Spend the rest of Thursday doing that, and Friday and our test review, which this is the bulk of your test review. We may not do a separate unique test review. And then Monday next week, it'll be the in-person test, except for the 2 people who have the extenuating circumstances that have been proven, and I'll deal with those 2 people individually. Are there any questions? Please use chat. I've got a very weak speaker on the unit that's recording this. If there are no questions, we're done for the day. See you Thursday.